In today's video, I'm going to take this rusty piece of old railway track and I'm going to turn it into a 25 kilo anvil for blacksmithing. This was a really fun hands-on project to build, no computer work, no planning, no CAD, just grinding, welding and machining. So let's get started. Over the summer of the first COVID lockdown, I went on a lot of long walks with my dog. And one day I came across this really tall bridge going across a stream. There was a lot of metal debris around the bridge that I think workers had just chucked off the bridge when they were building the railway line. And looking closer, I noticed a piece that looked suspiciously like a piece of railway track. I came back the next day with a mountain board and a tie-down strap and managed to get the piece of railway track fairly secured to the board. I also found lots of other nice useful bits of metal in and around the river that I took home with me. It was a 2 or 3 mile walk back to the car and it would have been almost impossible without this mountain board. So the piece of railway track that I got is about 1 meter long and probably weighs around 70 kilograms. This is way more steel than I'm going to need for a small anvil, so first job is to start trying to cut the piece off. Naively, I thought that this would be relatively easy using my small 115mm angle grinder. I've made a bunch of knives and cut through so much steel using a small angle grinder just like this, but I massively underestimated the thickness and the toughness of this railroad track. After attacking it for quite a few hours, all that I had done is put a small groove in it, and I burned through a bunch of discs and eventually just ended up burning through the angle grinder as well. So the cheap little underpowered grinder was out and it was time for something a bit more suited to this task. So I forked out for a Makita 230mm grinder. Way more powerful, way more fun, and much more suited to this task. The larger diameter blades with more torque and power make a humongous amount of sparks, which also look really cool on video. Even though progress was a lot faster with this bigger angle grinder, it still took quite a while and quite a few grinding discs to get all the way through the piece of railway track. Once I'm through, I sketched a very rough outline of the kind of design that I wanted, and it was time to begin shaping. The first step is to flatten the top. The railroad track has quite a large curve at the top and I want a flat anvil, so got to grind away all of that material. After a significant amount of grinding, the top is relatively flat. It's then time to move on to the sides because I don't really want rounded edges, I want nice sharp edges on the anvil. Once the sides are a bit more squared up, I can then think about starting to make some of the actual features of the anvil. I didn't have an exact design in mind, but I knew that I wanted a sharp horn on one side and a rounded horn on the other side. Since this anvil is going to be relatively small, I'm mainly going to be using it for detail work, so I wanted a horn on both sides for that. When the material is this thick, cutting is way quicker than grinding away the material, so I planned my cuts to remove as much material as possible before then grinding down the final surface. I'm pretty happy with the sharp horn that I've made on this side. This is one with 90-degree edges. I'm then going to flip it around and work on the rounded horn on the other side. Again, you know the drill here, same thing as before, just removing as much material as possible with the cutting discs before moving on to grinding the final shape. At various points throughout the grinding process, the railway track started to get quite hot, so I had to keep spraying it with water so that it was cold enough that I could actually pick it up and move it. It was also important that all of the vegetation around me was kept wet because of the ridiculous amount of sparks made by this massive grinder. Didn't want to set fire to anything in the garden. This is what the railway track looks like after most of the heavy stock removal. Because of the I-beam cross section of this anvil, when I hit it with a hammer it rings really loudly like a tuning fork. That's something that I want to change because that's going to get really annoying. When I was digging around in the river where I found the railway track, I also found this large piece of steel. I think this is a fish plate that they used to connect two of the tracks together, and it's quite nicely shaped to fit in this gap here to fill in some of the material. Thankfully, the piece that I have is double the length that I need it to be, so the first step was just to cut it in half. Unfortunately, during some of the shaping on these fish plates, I managed to burn out and destroy the large angle grinder. Thankfully it was still under warranty, so I sent it back to get a new one. So because I had the majority of the shaping complete on the striking surfaces, I could then move over to my milling machine while I wait for a replacement angle grinder to arrive. The milling machine makes it super easy to remove material very precisely, get all of the surfaces very flat and perpendicular to each other. This is as much for aesthetics as it is for functionality. Obviously a flat surface is really good, but it's going to also look way nicer if everything is symmetrical and perpendicular. The railway track material isn't fully hardened steel, but it is a lot harder and tougher than mild steel. And even with a lot of lubrication, it keeps wearing out the lathe tool that I've got in the fly cutter. When you see all of these sparks coming off the material, it's because the cutter's become dull and it's not cutting properly. So every 2 or 3 cuts, I have to take the fly cutter out and sharpen it on my bench grinder. Interestingly, you can also see how much the anvil moves around on the milling machine when it's in the middle of its travel, and that's because the bed is really worn out because it's a super old machine. This is a lot less of an issue at either end of the travel where there's less wear. It's not the ideal setup, but it got the job done, and I slowly shaved off the material 0.5 millimeter at a time. With a light finishing pass for the final cut, I actually got a really nice surface finish in the end, more than good enough for a piece of metal that I'm going to be smacking with other bits of hot metal. It was then time to machine the sides of the anvil, and there was a fair bit of material to remove here, because my angle grinding wasn't very precise. I first tried to do this side material with a high-speed steel end mill in the vertical spindle, but it completely chewed up and destroyed it with the hardness and toughness of this railway track. Thankfully this machine also has a horizontal spindle, so I can still use the fly cutter just in the horizontal spindle. And even with the interrupted cut, still gets a pretty nice surface finish. By rotating the anvil to different angles, I could carefully flatten all the different edges of the anvil, making sure that they were all perfectly vertical. So after a lot of cleaning up on the milling machine with the fly cutter, you can see that all of the edges are very nice and flat and perpendicular to each other. It's a couple of days later and a replacement angle grinder has arrived, so it's time to start shaping these fish plates so that I can weld them into the sides to fill in this material here. There's actually a lot of material that needs removing from these fish plates so that they're not overhanging the edges of the striking face of the anvil. I also wanted to remove any rust and grime from these edges of the anvil so that when I weld it together there's no contamination. Finally, after loads more cutting and grinding, I got these fish plates down to the right size so they could fit either side of the anvil and fill in this gap. So it's finally time to start welding these bits together. The best method for this to make the most solid anvil possible would be to heat everything up to like 1000 degrees and forge weld all of these pieces together. I don't have the means or the equipment to do that, so I'm just going to be stick welding it together. It's not going to be quite as strong, but it should still be good enough considering the fact that I've got some really heavy bevels in around all 4 edges of the fish plates. Should give me loads of surface area for the welds. Because I'm welding on such thick material, I've got my arc welder turned up really high to like 150 amps so that I can really burn these rods nice and deep into the material and get some good penetration. Also, I am by no means a good welder. I've never been a very good welder and I'm really out of practice at the moment because it's been a while since I did any. So none of these welds are going to look very pretty, but hopefully they'll be functional. Despite the bad welds on this thing, I actually really enjoyed putting it all together. And it was a lot of welding. Over the course of a day or two, I think I fed an entire 5 kilo pack of electrodes into this anvil. Not all of that is mass that was added to the anvil. I did end up grinding out a lot of welds where there was cracks or porosity because I wanted to make it as strong as possible. This is what the anvil looked like at the end of the welding process. It's not perfect, but I think it's good enough. This is never going to be used for heavy duty work, and if somehow something does fall off it, I can always just weld it back on. Now I've got those plates welded on the side, it's time to start the shaping of the round horn. There's a lot of material to remove, but the big angle grinder makes short work of it. The most difficult thing is keeping everything symmetrical. If this horn is asymmetrical, the anvil is going to look terrible. Also here I'm being really careful to keep the transition between the flat striking face and the horn nice and clean. One slip with the grinder and I could round over one of those corners and ruin the aesthetic. Once the shape was relatively close, I moved onto the small angle grinder and even some hand files for the final shaping. As you can see here, the hand filing was really slow, but it's perfect for removing very small amounts of material very precisely to make sure the two sides are symmetrical. A sandpaper flap disc gives a pretty nice surface finish when I'm smoothing everything out at the end. I also cut a couple of grooves into the base plate that could be used to bolt the thing down to a piece of wood. I gave the edges of the main striking face a 0.5 mm round over to make them more durable and less likely to chip or get dented. The sides on the sharp horn are still kept at perfectly 90 degrees. I then polished all of the striking faces with some Scotch-Brite and with a random orbital sander to make them nice and shiny. Here's the anvil after polishing, and I think it's looking pretty nice. There's still a bit of undercut and some holes in some of the welds, but I think it should be okay. The final step was to spray paint the anvil. I covered the striking faces with some masking tape, and then spray painted the rest of it black with some fireproof spray paint. Then, after pulling that tape off, we can have a look at the finished anvil. And I'm very happy with how it's come out. All of the edges are nice and square and symmetrical, and all of the transitions are nice and smooth. The anvil feels really solid, it probably weighs around 25 kilos. Like I said before, the railway track steel isn't fully hardened, but it is relatively tough still. As you can see, the ball bearing still bounces off it pretty nice, and you get a nice little bit of rebound with the hammer as well. For the small detail work that I'm going to be using this for, it should be more than enough. So time to give it a quick test. First things, I'm just flattening out a piece of copper pipe. I haven't got it secured properly yet, I need to make a proper stand for it, but at the moment it's just clamped down to the bench and it seems perfectly good enough for smacking really hard. The sharp 90-degree corners on this edge of the horn can be used to score and cut material. I want to try it with some hot steel for blacksmithing because that's what it's actually made for. Unfortunately, I don't have a working coal forge at the moment, but I do have this electric heat treat oven that I built a few years ago. It doesn't really get the steel hot enough, but it gives me kind of a rough idea of what it's going to feel like. Ideally, I want to get it a couple 100 degrees hotter for forging. And this is what the anvil looks like a year and a half later after some semi-regular use. I think it's held up pretty well. It's been really useful just to have on the workbench as something that I can use for striking on. The surfaces have gone a little bit rusty and I've had a couple of mishits which have dinged up the surface because the steel isn't fully hardened, but all in all not too bad and it's still very usable. You might notice that this is a re-upload of a video that I released about a year and a half ago. The original video got a copyright strike very early on and ended up barely getting any views I think because of it. But I've also got some new videos coming out. I've got some exciting new updates on the DIY CNC router project, and the next video of that series is going to be released later next week.